let's go ahead and review the definition of a function and revisit some terminology that you've probably seen before, but it's not a bad idea to look at it again. First of all, let's define a function, okay? So let's let x and y be two non-empty sets of real numbers. So let me go ahead and start making a little picture here. So let's say there's a set x. Contains a bunch of real numbers, okay? And here's a set y. They're non-empty, which means they contain some points or some numbers. A function from x into y is a relation that associates with each element of x a unique element of y. So if I wanted to draw a little picture here, I'll call my function f, okay? Numbers will go into our function f, okay? And then it will associate to exactly one number over in y, okay? So the biggest thing we have to remember about a function is that for each element in x, there is a unique element of y assigned to it, okay? A couple other parts that we need to remember is domain and range. What's the domain? Well, the domain of a function is the set of all possible values of the independent variable x. The numbers that go into the function are called the independent variables, okay? And those will be coming from the domain. The range of a function is the set of all possible values of the dependent variable. Usually we call them y's. So what do we have here? All these numbers over here represent numbers in the domain. All of our x values are the domain. And all possible y values will be called the range. Okay? Let's take a look at a typical relation. Here's an example of three possible functions. We'll figure out which one of these is actually a function. All right, so we have a relationship here. 0 goes to 1, 2 goes to minus 1, 3 goes to 1, etc. So notice, first of all, let's look at this relation. The domain is the set 0, 2, 3, and negative 1. The range is the set 1, negative 1, and 2. I don't have to repeat the 1 because it's already listed here. So the range will be the set of all dependent variables, all the y values, 1, negative 1, and 2. Now, we're asked to determine if these are functions or not. Now remember, the thing we have to remember about a function is that for each x element, there is a unique y element. So let's see. 0 goes to 1, 2 goes to minus 1, 3 goes to 1, negative 1 goes to 2. This is a function. For every x element, okay, there's only one corresponding y element. This is a function. Okay? Let's look at this one. The domain, 0, 2, 3. We don't have to list the 2 again. The range, 1, 4, negative 1, and 2. Now let's check to see if this is a function. Notice 0 goes to 1, 2 goes to 4, 3 goes to minus 1, but 2 also goes to 2. So notice 2 goes to 4, and 2 goes to 2. Here's an element of x that has two different corresponding y values. Remember, if it's a function, for each element x, there is only one unique element y. So here's an example of a relation that is not a function because I have a 2 going to a 4. A 2 also is a correspond to 2, so this is not a function. Okay? Let's figure out the domain of this relation. The domain, 1, 2, 3, and negative 4. The range, let's go ahead and write this. The domain is 1, 2, 3, and minus 4. The range, notice the y values are always 3. So the range just has one element, 3. Now let's check to see if this is a function. For every element x, let's see if it goes to just one unique element y. Well, 1 goes to 3, 2 goes to 3, that's okay. 3 goes to 3, negative 4 goes to 3. There's no repeats. Remember up here we had a 2 going to 4 and a 2 going to 2. But here, all my elements x just go to one element. So this is a function. Okay? And last, let's talk a little bit about function notation. Here's a typical function and what it looks like. We have this f of x. That's how we'll read this. F of x equals square root of x. Okay, so that's how we'll read that function. This is not multiplication. This is just notation. This is not f times x. We'll just call it f of x. So this is how we will see these functions. Now let's go ahead and take a look at this function. What we'll do is we'll stick a x value into the domain. So let's just pick x equals 4. Let's figure out what the corresponding y value is. So if I shove a x equals 4 into my function, I want to know what f of 4 is. And we'll talk about this later in more detail in future lectures. But if I plug a 4 into the function, I get square root of 4, which is 2. So notice this is my dependent variable, x. This is the independent, sorry. The independent variable is the x values. The dependent is the y values. So the y value depends on the x. You plugged in an x, it will spit out a y value. So 4 corresponds to 2. And we can find infinitely many points. Notice if I plugged a 1 in, a 1 would correspond to a 1. A 9, if we plugged a 9 in, f of 9 would be 3. A 9 corresponds to 3, etc. So you can see these relations that we're getting. So here's just the way we'll describe our functions, and here's the corresponding relations, or these are the corresponding x and y coordinates. And we'll graph these things a little bit later. Most of you have seen functions before, but what you need to remember is the definition. You might want to write that down. Okay? And the biggest thing you have to remember about the definition is that for every element in x, there is just one corresponding element in y. The domain, that's the independent variable. The range, those are the dependent variables.